G'day everyone. We're out at MacDill Air Force Base today, and you can see behind me we have the Spectre Shelter XL erected. This is the first time it's been erected. Over here you can see we have modules. So each module in the Spectre Shelter XL is tied together right here by a industrial military grade zipper. It is so robust, and it's incredibly easy to zip up, right? So each module enables you to expand or contract. This model here is 40 feet long by 20 feet wide by 13.5 feet high. It can go up to 60 feet, 80 feet, or even 100 feet long, each one of these buildings. Inside here, I'll take you on a tour inside. You can see how much space we have. So what we've done is we've situated D-rings around the edges of the entire thing. You can see how hard this is. This is inflated, 9 psi, because we have 2,400 structural supports per square foot, or 26,000 per square meter. And they bridge from this membrane, the inner membrane, to the outer membrane. So when we inflate this with 9 psi, the structural supports are pulling the material together, the PSI is pressing it outward, and you have this incredible rigidity as a result. Now, we have, I'll take you outside soon and show you the pumping system that we use. It connects to a manifold and keeps this whole thing inflated properly, dynamically, right? You can leave this setting in the field for days on end, the way it is, or you can have the passive pumping system operating if you have a base, for instance, that's stationary for a long time. So we've situated D-rings around the edge for equipment. So if it's whatever it may be being used for, even if it's a barracks, the men can hang their equipment on the D-rings. We're going to be putting D-rings a bit higher as well for individual lighting for each of the beds when they're in here. We have D-rings across the ceiling, and that's to hold our flexible plenum that's designed and built by Milton Manufacturing out of Detroit. What a great group of people, and I tell you what, they're the best in the business. So inside here we have posable kind of air outlets that you can kind of direct the air. This fills up and it expands, and underneath this are D-rings for strip lighting, for kind of community lighting for the building itself. So when this goes up, it's a very quick process. You lay down the modules on the ground, like we have here, and you zip them together. And you do that right like this. It's that easy. You can see how big the zipper is compared to my hand. It's a massive zipper, okay? And so you zip it together, you inflate it, a little bit, you zip the internal zips together, and then you push a button and you have yourself a barracks or a building. 4 people, approximately 30 minutes to erect this building. We have ducting that's already prepared for any type of environmental control unit that you may have. These here are blackouts for the windows. They inflate and they go into the window region up here. And the reason they do this is while you're in here, you are completely invisible from thermal imagery scans. So we want to make sure that we enable that with the windows as well. So if you want to maintain invisibility, those get inflated, they get popped into the windows, and you are invisible. So I've left this undone, this zipper here, so you can again see just how large the teeth are in comparison to my hand. It's a pretty big zipper, I'll tell you. And then over here we also have our electrical ports, so for electrical cables. What an amazing product. This is an inflated building, and there are no pumps running right now. It's been up for a couple of days now, and it's as hard as a rock. Now we're going to go over here, and we're going to have a look at the pump and the manifold system. So this is the air pump that we utilize. This is the inflation side. This is our manifold, and these connect to each of the inflation valves, right? So as you can see, we have an inflation valve here. This is a pressure relief valve as well. We have handles on the outside of the building, but right here we will, this is the inflation side. When we want to deflate, which we'll do here very soon, we're going to move this manifold from here to the back, and we'll deflate the modules, and we'll take this building down in a matter of minutes instead of using a crane or any of the other stuff that you might have to use in order to take down buildings. So you can see how these modules end up rolling up into just a little duffel bag, actually. So I'll show you here. This is the duffel bag on the ground right here that each one of these modules rolls up into. So this module here, this entire module, all the way to the other side, right here, fits into that duffel bag. This all vacuums down. This entire building vacuums down into duffel bags, and those duffel bags are then transported. There are no structural members to remember. There are 3 part numbers: the end walls, the side walls, one with a window, one without. Now, it comes with an optional inflatable floor, or you can have a flat floor, or you can have no floor. It just depends on how you prefer your buildings and what type of an environment they're going to be installed in. So whether it's cold or it's hot, it makes no difference, because we have an air gap between this membrane and the outer membrane. So I'm standing in here right now, and it's cool inside this building. It's cool inside this building because the sun is hitting the outer membrane, and there's nothing but an air gap between that outer membrane and this inner membrane. So it's very quick to cool these units with an external environmental control unit if you would like to.